Right, welcome to Siyafunda once more. I'm Mr. Spusiso Kanyila. Let's move on with our theorems here. Two tangents from the same point outside the circle are equal up to the point of contact with the circle. Let's create the diagram. If I've got a circle, two tangents, let's create tangents there. If this is one tangent, this will be another tangent. What is this theorem saying? Whenever I've got two tangents that are coming from the same point outside the circle, these tangents will be equal up to the point of contact with the circle. In other words, it says that this side is the same as this side. Right. If we need to prove that this is true or not, if we want to prove that this side is equal to this side, it will take us back to congruency as well. Let's create a circle here. If we create a circle here, our construction, if we create a circle here, such that we have this line. What is the name of this line? It is called the radius. And what is the name of this line? From here to there. Remember the previous theorem that we've just done. We said whenever a radius meets a tangent, 90 degrees is formed. This is a tangent. This is a radius. So what is this saying to us? This is 90 degrees. This is a tangent. This is a radius. What is this saying to us? This is 90 degrees. Remember, we want to prove that this side is equal to that side. Let's create two triangles here. Cut this one. This is my construction. Remember, this was supposed to do in dotted lines because it is the construction as well. This is the construction. It should always be in dotted lines. Our construction must always be on dotted lines. Look at this other one. This is our construction. Now, from our construction, we established that this angle is 90 degrees. We also established that this other angle is also equal to 90 degrees. Now, if this is A, B, C, let's call this O. We've got two triangles there. This triangle and this triangle. Remember, we want to prove that this one is equal to that one. Let's do this thing. We are going to have to prove congruence between the two triangles. Between this triangle, let's call it ABO. I'm going to prove it in the triangle ABO. And this was ABO and triangle ACO. And triangle ACO. I'm going to prove that the two triangles are congruent. Remember, let's just sketch them separately so that we'll see what we're talking about. We've got this triangle. Let me just put it in this way. This triangle. This is the one. What I've done, I've just taken it up this way. So 90 degrees is here. What value do I have there? It is A. I've just put it like this. So this is O. Right, that's one triangle. A, this is O. Oh, wait. I've just taken it like this. Yeah, O is there. This is 90 degrees. If I'm taking this one and just take it and flip it and put it in here, I will have something like this as well. I've taken this triangle, I've just flipped it in this way and put it up. So this is A. This part, I've just flipped it to this side into 90 degrees. So what will I have there? This will be O. So these are the two triangles that we have. We want to prove that these two triangles are congruent. Remember the main thing that I want to prove. What is it that I want to prove here? RTP. I want to prove that AB is the same as AC. This is what I want to prove. I want to prove this fact that AB is equal to AC. Two tangents from the same point outside the circle are equal. That's what we want to prove. Whether these two tangents that are coming from outside the circle, are they the same? That's exactly what we want to prove. Right. Number one, we said we had our construction. What was our construction? We joined radius OB. We join radius, radi, because our 2, it's OB and OC. And also join line OA. Just to separate the two triangles. I want to have this triangle and this triangle. Then check whether this isn't equal to that one. Now, once I have this scenario, let's look at this one. This angle is equal to this angle, 90 degrees. Where did I get that information from? Tan radius. There's a radius, there's a tangent. Whenever they meet, they form 90 degrees. So in this triangle, we've just established that this angle here, in this case, what do we have here? It is B. What do we have that side? It is C. Remember what we want to prove. We want to prove that AC, which one is AC? This one, AC. This is what we want to prove, AC. AC is equal to AB is equal to AB. This is what we want to prove, that this side is equal to that. That's what we want to prove. Because these are the two tangents from the same point. Let's do this thing. We've just said now angle B is equal to this angle is equal to this one. Angle B is equal to angle B. Reason, they're both equal to 90 degrees. Right? That's the first thing. Number two, in other words, we've just proved one angle. Number two, we can prove that OB is equal to OC. OB equals to OC. That's the second one. OB equals to OC. Why are these two the same? They are a D. The distance from the center of a circle to the circumference is the same as this one. This distance up to here is the same as all this distance, radi, radi, radi. So the distance from the center of a circle up to the circumference is always the same in the cycle. Right, so at the moment, we've just proved that this angle is equal to that angle, which is angle, or 90 degrees. Number two, we just proved that OB, which is this one, is the same as OC, which is this one in this particular case. That's what we need to write there. Let's see what we've done. We've said OB is equal to OC, OB equals to OC. At the same time, angle B is equal to C, which you can see here. Angle B is equal to C, both equals to 90 degrees. Angle B equals to, oops, let's correct this one quickly. We are saying angle B, this angle, is equal to angle C. Yes, it should be equal to angle C, not B. So, because we're comparing the two triangles, we can't have B and B there. We've got B and C. So we're comparing these two angles that they are equals to 90 degrees. Right, let's look at something else. Let's look at the side. Let's look at the side. This is side AO. Do I have AO this side? Yes, I do have AO in this triangle. Do I have AO in this other triangle? Yes, I do. What do you call that? So we can say that AO in this triangle, where is it? Where is my triangle? AO in this triangle is equal to AO in the other triangle. AO is equal to AO. So AO is the same as AO on the other triangle. Why are these two the same? They are common sides, common. Right, das doesn't too much. We started by saying, in these two triangles, we said this angle is equal to this angle, which is 90 degrees. Number two, we said this side is equal to this side, which is a side. Remember the four cases of congruence. Number three, we are saying this side is equal to this side. Number two, what type of a triangle is this one? We call this a right angle triangle. So the longest side is called what? The hypotenuse. So in other words, this hypotenuse is the same as this one. This one is the same as this one. This one is the same as this one. All right, what is it that we want to show? We want to show that AB, which is this one, is equal to the yellow one that side, which is AC. How do we do that? For the fact that we've shown that this is 90 degrees, this is radi, and what is this side called? What is this side AO called in the right angle triangle? The side opposite the 90 degrees. This side which is opposite 90 degrees, this side which is opposite 90 degrees, we call it the hypotenuse. So in other words, this is the hypotenuse, this is the side, this is 90 degrees. So in the case of congruence that will work here, we can conclude that triangle ABO, which one is that? ABO, ACO, right. We can say that triangle ABO is congruent to triangle ACO, ACO. Why are these two triangles congruent? Why are these two triangles equal in all respect? It's because we've got 90 degrees, which is this one, 90 degrees. We've got the hypotenuse, which was a common side in this particular case, and a side. 90 degrees hypotenuse and a side. So this is why these two triangles are congruent. When we say these two triangles are congruent, we mean they are equal in all respects. In other words, their corresponding sides are the same, their corresponding angles are the same. Let's look at it. This angle corresponds to this one, therefore this. The fact that we are saying these two are congruent, we mean that their corresponding angles are the same and their corresponding sides are the same. This angle will be equal to this one, this angle will be equal to this one, and of course A will be equal to angle A. It also means that this side corresponds with this one, therefore they are equal. This side corresponds with this one, therefore they are equal. This side then will be equal to this one. We are taking that from congruency. Then we can say that AB, which is this side, AB is equal to this side AB must be equal to side AC. Why are we saying these two are the same? AB and AC, they are the same because we took it from congruency. We took it from the fact that the two triangles are congruent. If these two triangles are congruent, therefore the corresponding sides are the same. In other words, if I take this triangle and put it exactly on top of this one, we won't see that there are two triangles on top of each other because they are equal in all respects. So that's how we'll go about proving that AB is equals to AC. We use the factor of congruency, look at the two triangles, divide them, then the case that we'll be using is 90 degrees hypotenuse on the side. Thank you.